Welcome to the lesson on battery theory. In this lesson, we will look at the history, purpose, and composition of a battery. Let us now look at our lesson objectives. After completing this lesson, you will be able to describe the people and events that led to the modern battery concepts. You will be able to explain the purpose of a battery. Next, you will be able to describe the chemical reactions in a battery. Finally, you will be able to define an electrode. Understanding how batteries work is important because they are at the heart of battery electric vehicles, BEVs, and play a vital role in determining their performance, range, and overall dependability. A battery is a device that stores chemical energy and converts it to electrical energy through a chemical reaction. It is most commonly comprised of one or more electrochemical cells. As a technician, a large portion of your responsibilities will involve the maintenance and repair of vehicles equipped with BEV batteries. Your knowledge will be critical in determining the causes of reduced battery range, power loss, or charging issues, monitoring battery health and recommending services to optimize its life, ensuring proper procedures are followed and avoid electrical hazards, and keeping up with the advancing battery technologies and application strategies. Understanding battery theory will allow you to meet these challenges and ensure the best performance of these vehicles. In this lesson, we will focus on the history of batteries, the electrochemical theory, the basic composition of a battery, and the electron flow in a circuit. In this section, we will look at the history of batteries. Let us now look at what started the evolution of batteries by going back in time. In 1748, Benjamin Franklin, one of the founding fathers of the U.S., a key figure in American history and an inventor of the lightning rod, is credited with coining the term battery. He used it to describe a series of linked glass jars, Leyden jars, used in his electrical experiments. These early batteries paved the way for future developments. In 1780, Luigi Galvani, an Italian doctor and scientist, conducted experiments demonstrating what we now understand as the electrical basis of nerve impulses. He termed this as animal electricity. His work provided a foundation for future inventors like Alessandro Volta. From 1792 to 1800, Alessandro Volta made a significant breakthrough by inventing the first practical method of generating electricity through a chemical reaction. His voltaic pile consisted of two different metals separated by a moist material. This invention, the first actual battery, allowed for the storage of electrical energy, volts. The voltaic pile, invented by Alessandro Volta around 1800, is considered the first true battery capable of producing a continuous flow of electricity. It marked a significant leap forward in harnessing and utilizing electricity. The design consisted of alternating discs of dissimilar metals stacked together like copper and zinc. These discs were separated by layers of a moistened cloth or cardboard soaked in an electrolyte solution, often salt water. The contact between the dissimilar metals and the electrolyte triggered a chemical reaction to enable it to function, generating a small voltage difference at each junction. Stacking these pairs of metals in series increased the overall voltage produced. While not very powerful by today's standards, the voltaic pile was groundbreaking. It provided a reliable and relatively constant source of electricity. The voltaic pile's invention sparked a surge in scientific exploration and experimentation with electricity. It paved the way for developing more advanced and powerful batteries that continue to revolutionize various fields, including battery electric vehicles today. In this section, we will look at the electrochemical theory of a battery. For this lesson, we will explore the 12-volt battery. This will provide you with a foundation for other types of batteries and a battery pack within BEVs. An interesting fact is that batteries do not store electricity directly. Instead, they store chemical energy in the form of specific materials within their electrodes, anode and cathode. A chemical reaction between these electrodes releases electrons, creating an electric potential, voltage. Like a water reservoir pushing water to a pump, a battery uses chemical reactions to create a flow of charged particles that power a BEV. The electrochemical theory bridges the gap between electricity and chemicals. It explains how chemical reactions, like those in batteries, can generate electricity, and conversely, how electrical energy can drive chemical changes, as seen in electrolysis. Batteries store chemicals that react with each other, releasing electrons that flow through a circuit as electricity. This flow of electrons creates the current that powers the battery. A battery's primary function is to store chemical energy and convert it into electricity as needed. This process involves chemical reactions that generate electric potential and store energy. Similarly, everyday items such as fire logs store energy within their chemical bonds, which are released as heat when burned. We will focus on 12-volt batteries, as 12-volt batteries are more straightforward to understand. Learning how 12-volt batteries work will give you a solid foundation for understanding more complex batteries like lithium-ion. Think of it like learning math. You start with addition and subtraction before moving on to calculus. So, what is a battery made of? A battery consists of 6 2-volt cells connected in series. Each cell is composed of several positive and negative electrodes made of pure, spongy lead and lead oxide. Electrodes connected in series are immersed in a dilute solution of sulfuric acid. Conversion of electricity to chemical potential energy. Before a battery can store energy, the electricity it receives must be converted into a form that can be stored chemically. This process involves transforming electrical energy into chemical potential energy, stored within the battery until needed. Composition of a battery. A battery comprises 2 terminals, commonly referred to as the positive and negative terminals. These terminals are made of dissimilar metals and immersed in an electrolyte chemical solution. The electrolyte serves as a medium for ions to move between the terminals. Operation within a circuit. When a battery is connected to an electrical circuit, a flow of energy occurs. Electrons move from the negative terminal through the circuit to the positive terminal, while ions in the electrolyte also move to maintain electrical neutrality. This movement of electrons and ions constitutes the flow of electricity within the battery-powered circuit. Discharge process. During the discharge process, energy is released from the battery as electrons flow from the negative terminal to the positive terminal through an external conductor, such as a wire. This flow of electrons powers electrical devices connected to the circuit, such as lights, motors, or electronic devices. In this section, we will look at the section on battery basics and focus on the basic battery composition of a 12-volt battery. Learning about a 12-volt battery will provide you with a foundation for other types of batteries and a battery pack within BEVs. A battery is a device that contains one or more cells. Each cell converts chemical energy stored within it into electrical energy. 4 main components are in a battery cell: electrodes, electrolyte, separator, and cell container. Electrodes. The electrodes are the positive and negative terminals of the cell, labeled in the image as POS electrode, positive, and neg electrode, negative. Chemical reactions occur at the electrode surfaces. Electrolyte. The electrolyte is the substance that is between the positive and negative electrodes. The electrolyte is a conductive solution that allows ions to flow between the electrodes. These ions are necessary for the chemical reactions that take place within the cell. Separator. The separator is a porous membrane that prevents the electrodes from physically touching but allows ions to pass through. The separator is located between the positive and negative electrodes. Cell container. The cell container holds all the components together and protects them from the environment. The fact that the electrolyte and separator are not electrically conductive themselves plays a vital role in battery function. This prevents uncontrolled electron flow between the electrodes when no external circuit is connected. This minimizes self-discharge, a condition where the battery loses its stored energy even when not used. In essence, the electrolyte and separator work together to ensure that the battery's energy is only released when a load, external circuit, is connected, maximizing its efficiency. Let us now look at the electron flow and electrical potential. Initially, the battery terminals connect to an external circuit. Next, the chemical reactions at the electrodes cause the electrons to be released from one electrode, anode or negative, and attract to the other, cathode or positive. This creates a voltage difference, electrical potential, between the terminals. Lastly, when a circuit is connected across the terminals, electrons flow from the negative terminal to the positive terminal through the external circuit. This flow of electrons is what creates the electric current that powers devices. In this section, we will look at the electron flow in an external circuit using the example of a 12-volt battery. The example of a 12-volt battery will provide you with a foundation for other types of batteries and a battery pack within BEVs. In the context of a lead-acid battery, electron flow in the external circuit during discharge follows a specific pattern. The positive electrode, or cathode, functions by consuming electrons from the external circuit as the battery discharges. This consumption of electrons results from the reduction reaction occurring at the cathode during discharge. Conversely, the negative electrode, or anode, releases electrons to the external circuit during discharge. This release of electrons is associated with the oxidation reaction taking place at the anode. Together, these processes facilitate the flow of electrons through the external circuit, allowing the battery to supply electrical energy to power devices or systems connected to it. During discharge, chemical reactions occur within the cell, involving oxidation and reduction processes that either bond or release electrons. The positive electrode undergoes reduction, while positive ions travel through the electrolyte to the negative electrode. Conversely, the negative electrode oxidizes and receives positive ions passed through the electrolyte. In a typical 12-volt automotive battery, ion flow during discharge involves specific materials and processes. The positive electrode, composed of lead dioxide, serves as the site where reduction reactions occur during discharge, leading to the consumption of electrons from the external circuit. Meanwhile, the negative electrode, made of sponge lead, undergoes oxidation reactions during discharge, releasing electrons to the external circuit. The electrolyte, which consists of an aqueous sulfuric acid solution, facilitates ion movement between the electrodes. Specifically, sulfate ions in the electrolyte act as the medium through which positive ions migrate from the positive to the negative electrode during discharge. As a result of these reactions, lead sulfates are formed, contributing to the overall discharge process and converting chemical energy into electrical energy within the battery. Let us now recap what we covered in this lesson on battery theory. Batteries play a critical role in battery electric vehicles, impacting their performance, range, and reliability. Understanding battery theory will equip you to diagnose issues, perform preventative maintenance, safely handle high voltage, abbreviated as HV equipment, and stay updated on advancements. We delved into the history of batteries, starting with Benjamin Franklin's coining of the term battery in 1748. We then explored Alessandro Volta's invention of the first true battery, the voltaic pile, in 1800. This breakthrough paved the way for modern batteries. The core concept of batteries is that they don't store electricity directly. Instead, they store chemical energy in their electrodes. Chemical reactions between these electrodes generate electricity upon demand. This process is explained by electrochemical theory. A typical battery cell consists of four main components: electrodes, positive and negative terminals; electrolyte, conductive solution allowing ion flow; separator, porous membrane separating electrodes but allowing ion passage; and cell container, housing all components. We explored electron flow during discharge in a lead-acid battery. The positive electrode, cathode, consumes electrons from the external circuit, while the negative electrode, anode, releases electrons. Finally, we examined ion flow during discharge in a lead-acid battery. Positive ions move from the positive electrode to the negative electrode through the electrolyte, while electrons flow in the opposite direction through the external circuit. The ion flow in the electrolyte is always the opposite to the direction of the electron flow in the external circuit. This combined flow generates the electric current. Thank you.